Let's do a second example of molality-molarity conversions. So just to remind you that molarity is the moles of solute over liters of solution, and molality is moles of solute over the kilograms of solvent. All right, so here we've got a problem where we're given the molality, and this time we want to get the molarity. And this time the solution's much more concentrated, and as a consequence the density's not equal to 1. So this will be a little bit more interesting than the previous problem. So let's write down what we know. We know we've got 5.7 moles of sodium chloride for every 1.0 kilogram of water, since we're talking about molality. So let's see if we can put this closer to molarity. Remember, molarity, we wanted it to be moles of stuff over the volume of solution. So first, we're going to have to figure out how much solution there is. And right now, we've just got water. So we're going to have to figure out what the mass of sodium chloride is and add that into this. And then we can use the density to get the volume. So let's do this in steps. First of all, this amount of sodium chloride, what mass is that? So we say we have 5.7 moles of sodium chloride. So we need to get a periodic table out and calculate the molar mass of sodium chloride. And we see this is 23 and this is 35.5. So we get 58.5 grams of sodium chloride for every 1 mole of sodium chloride. So we can cancel our moles and get the grams, and we get that it's 333 grams of sodium chloride. So that's how much sodium chloride is dissolved in 1 kilogram of water. So we can say that the total mass of solution that corresponds to this much sodium chloride is going to be the sum of the water mass and the sodium chloride mass. So the total mass we have to calculate to get the total volume. So we've got 1,000 grams of water, and we've got 330 grams of the solute, the sodium chloride. So we've got 1,333 grams of solution. Okay, so now we're not just looking at the solvent, we're looking at the whole solution. And since we have the density of the solution, we can use this mass of solution to get the volume. So let's do that. So the total volume of solution is equal to the mass and now we have to convert from mass to volume. So we have to be careful here. The density is given in kilograms per liter. So if we want, we could change this to kilograms. So we have to divide by 1,000. So now we have 1.333 kilograms. So we said that there are 1.2 kilograms for every 1 liter. Okay? So we can check to make sure we've done the conversion right by looking at our units, and we can see we can cancel kilograms with kilograms. So dividing by the density was the correct thing to do. And so this comes out to be 1,000, we're doing liters now. So 1.111 liters of solution. Okay, so notice we said that's how much solution volume corresponds to this much moles of solute. So really we've just got one last step that's to divide. So let's do that on the next page. So the concentration in molarity for our sodium chloride is going to be the number of moles. We said 5.7 moles of sodium chloride divided by the total volume of solution, which we said was 1.111 liters of solution. And that is going to equal 5.1. I'm going to go ahead and round a little bit here because our initial data was only 2 sig figs. So we end up with 5.1 molar, And remember that we started with 5.7 molal. So when you have a fairly concentrated solution, even when it's in water, there's a significant difference between molarity and molality. And of course, there's always going to be a big difference if the solvent's not water, because then of course the density won't be equal to 1 kilogram per liter.